Now we're going to work through finding the stationary points and their nature of this function. So the first thing we got to remember is what a stationary point is, and that occurs when our derivative is equal to 0. So now we're just going to have to find our derivative f prime of x. Well, that's going to be 3 times 3, which is going to be 9. X to the 3 minus 2 is 2. Now we're just going to find our derivative of our original function. So our f prime of x is going to be equal to 3 times 3 is 9. X to the 3 minus 1 is 2. Minus 4 times 1 is 4. And x to the 1 becomes x to the 0, which is equal to 1. The plus 1 again just disappears. Now that we have our f prime of x, we set this equal to 0. So we get 0 is equal to 9x squared minus 4. We take the 4 over, so we get 4 is equal to 9x squared. Then we divide through by 9, so we get 4 over 9 is equal to x squared. So then we take the square root, we get x is equal to plus or minus the square root of 4 over 9, which is going to give us plus or minus 2 over 3. Now that we've found when our derivative is equal to 0, we can find the stationary points. So let's put our first value of x in. So we get f of 2 over 3, and that gives us 3 outside of 2 over 3 cubed minus 4 outside of 2 over 3 plus 1. Solving this out, we get 3 times 8 over 27 minus 4 times 2 is 8 on 3 plus 1, which is equal to minus 7 on 9. Now we'll find our other stationary point by doing the same thing. So we'll look at our f of minus 2 over 3. So we're putting this in, we get 3 outside of minus 2 over 3 cubed minus 4 outside of minus 2 over 3 plus 1. So here we get 3 outside of minus 8 over 27. And we've got 2 negatives here, so they join together to become a positive, and we'll get 8 over 3 plus 1. And that gives us 25 over 9. Now that we've done that, we just need to have a look at our type of stationary point. So to do that, we're going to be drawing our graphs. Because we have 2 stationary points, we need 2 graphs. So our first graph will be looking at the point minus 2 over 3, 25 over 9. And our second graph, we're going to be looking at 2 over 3 minus 7 over 9. We're also going to be needing to know our derivative, so I'll just write this here. I'm going to put in our details for when we have our stationary point. So f of x is 0 and our f of x 0. Now we're going to think with our first graph, what's a point that's slightly higher than our current stationary point, so our plus h. Well, it doesn't need to be hugely far, but it doesn't need to be hugely close. So if we look at our derivative, a nice easy x to choose that's greater than minus 2 over 3 is x equals 0. 0 is larger, more positive than minus 2 over 3. So when we put in 0 into our derivative, we end up with a negative 4 as our result. So that means that we get a negative here. So that means our slope is going down. Now we need to look at a point that's slightly less than our stationary point. So choosing a nice easy number in this situation would be minus 1. Why? Because, well, minus 1 squared is minus 1 times minus 1, which is just going to be 1. 1 times 9 is going to be 9. Minus 4, 9 minus 4 is going to be 5, so that's going to be a positive. So our graph goes up. So we can already see that our point minus 2/3 25/9 is going to be a maximal point. Now let's do the same thing for our other point. Now let's do the same thing for our other stationary point. First, we're looking at a point that's slightly lower, so 2/3, an easy one is going to be the 0 again, mainly because 0 is less than 2/3. So if we add 0 into our derivative, we get 0 squared times 9 is going to be 0, so it's going to be negative. So it's negative, it's going down. And then we can have a look at a point that's higher than our stationary point. So seeing our stationary point occurs at 2/3, a number that's higher than that would be when x is equal to 1. So then we can put that into our derivative. So 1 squared is going to be 1, 1 times 9 is 9, and 9 minus 4 is going to be 5. So that gives us a positive value, and our graph goes up. From this, we can see that our point 2/3 minus 7/9 is going to be a minimal point. Now let's have a look at this on a graph. Our purple line here is our original function, so our 3x cubed minus 4x plus 1. And then putting in our stationary points, which will occur down here and up here, we have our point down here at 2/3 minus 7/9, and our other point of minus 2/3, 25/9. So we've now determined our stationary points and found whether they were maximum or minima, or an inflection point.